This video is going to cover the 4-6 warm-up and then the 4-7 notes. So we start 4-6 warm-up with tangent. Remember, for tangent, we are going to identify A. So A is 1. And then we take what's next to it, the x plus pi, set it equal to negative pi over 2 and positive pi over 2. So I'd subtract pi, which is 2 pi over 2. And I get x equals negative 3 pi over 2. Subtract pi. And I get x equals negative pi over 2. And then those are your middle two asymptotes. The b is 1 here, so the period is pi over b, which would be pi. So for the one on the left, we subtract the period, which is that 2 pi over 2, negative 5 pi over 2. And to the one on the right, we add the period. And then those are our 4 asymptotes. So I've got negative 5 pi over 2, negative 3 pi over 2, negative pi over 2, and positive pi over 2. And then those are our asymptotes. We have to find the point halfway between. So halfway between negative 5 pi over 2 and negative 3 pi over 2 would be negative 2 pi. Halfway between negative 3 pi and negative 1/2 pi would be negative pi. And then halfway between negative pi over 2 and positive pi over 2 would be 0. And then we would plot A, which is 1. And we're going to go up at the quarter and the 3/4. At the 3/4 we go up, and on the 1/4 we go down. For cotangent, A is 1. B this time is pi, so the period is pi over pi, which would be 1. We set what's next to it equal to 0 and pi. Divide both sides by pi, and I get x equals 0, x equals 1. From the left, we're going to subtract the period, which is 1, so I get negative 1. On the right, I'm going to add the period, so I get 2. So I've got negative 1, 0, 1, 2. Those are your asymptotes. Halfway between is negative 1/2. Positive 1/2, and 3 over 2 are 1.5. Eyeball the quarter and the 3/4 point. This time it's cotangent. So I start up on the left and then go down on the right. Okay, now we go to number 3. So number 3 is cosecant, which means we're actually going to graph sine first. My A here is negative 2, so this is upside down. The amplitude is 2. The B is 4, so the period is 2 pi over 4, which is pi over 2. So first key point is 0, and then pi over 2 times 1/4. Pi over 2 times 1/2, pi over 2 times 3/4, and then pi over 2 is the last one. Mark those on your x-axis, so 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. The amplitude again was 2 and negative, and it's sine. So I'd start at 0, I'd go down to 2, up, up. And my sine curve looks like that. We need to extend it one more so we get the extra asymptote. So we've got one here, 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 and here, and then come the parabolas. And that's your cosecant. And last but not least, the secant. So this would be cosine of x minus pi over 2. The A is 1, which is your amplitude. The B is 1, which means the period is 2 pi. Our key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then to each of these, we're going to take our phase shift, which is pi over 2, and add it. It would be 2 pi over 2, so 3 pi over 2, 4 pi over 2, which is 2 pi. This would be 4 pi over 2, so 5 pi over 2. Okay, this time it's cosine. So we start at the 0, go up to the amplitude. Oh, no, sorry. Start at the amplitude. Down, down, up, up. That would be cosine. You're going to drop both sides so you can get your asymptotes. And then your parabolas. And there's the 4 different curves.
We are going to do the last section today, which is 4-7. 4-8 is extra practice on the right triangle trig problem. So you can, there are good practice problems there, but we're not going to actually do notes on 4-7. So we start with the inverse sine function, okay? So now what happens with this section is, up till now, I was giving you an angle and you were giving me the trig function. So if I said, tell me sine at pi over 6, hopefully by now we could say that would be a half. Now it's the reverse. I am going to give you the trig function. You are going to give me the value, the angle itself. So you will give me theta. There are restrictions on these, okay? The inverse sine function goes from, the x goes from -1 to 1. So I can never give you something bigger than that. And on my unit circle, the y goes from negative pi over 2 to positive 2. That's probably the most important thing on this slide, is the restriction on the angles that you can use, okay? So, which is the same as the range here. So what's going to happen is I'm going to say to you something like, give me, like I'll give you, let me just don't grab so I don't use the same example I'm about to use. Yeah, okay. So it'll say sine -1 of x, or theta, or I think it's x always, equals 1/2. Find theta is your goal. So what you're going to do is, again, lucky you guys, you can use your unit circle. I'm going to look at my unit circle. And I'm going to find all the values of theta, again, my angle, where my sine is a positive 1/2. So if you look at your, if you look at your unit circle and you go around your circle, right, you're looking for where sine, which is your y, is 1/2. And that happens here and it happens here. Now, there is only one answer for these questions. It's not a this or that, because we restrict what quadrants we use for these angles. So for sine, and that's what this negative pi over 2 and positive pi over 2 is, for sine we use the negative angles in the 4th quadrant and the positive and the angles in the 1st quadrant. So for sine we only use the negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and pi over 2. So we restricted to the right side of the unit circle. So if that's the case, now I should only have one answer. From the right side of my unit circle, where is sine 1/2? That only happens at pi over 6. So there is only one correct answer for these. You do not use your entire unit circle. Sine is restricted to the right side of it. Even furthermore, the negative angles of the right side. So I don't use 11 pi over 6 and 7 pi over 4. I use negative pi over 6 and negative pi over 4. This is my initial sine curve, right? This is why we restrict it the way we restrict it. So if I were to restrict it, obviously if I was to go from 0 to 2 pi, this is no longer a function, okay? It's a function, sorry, it is a function. It doesn't have an inverse because it would fail my horizontal line test. You remember your inverse test was a horizontal line? That segment there would fail a horizontal line test, which is why that can't have an inverse. So we restrict it to only half of it, but we need the half that has positive and negative values, which is why it goes from negative pi over 2 to positive pi over 2. Really? I don't need to understand why. I just need to understand that we only use those angles, okay? But if the bigger picture is y, that's it. Because we
do red, we do the blue.
Correct.
Okay.
Which is what we just highlighted on our unit circle, which is what I'll tell you to do. You don't need to take it from your curve. Okay, so these are the only angles I can ask you without a calculator. It has to be negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0. So this is like your bank of answers for all your arc sines, okay? It only comes from the right side, which is negative pi over 2 to positive pi over 2. And without a calculator, these are the only ones you can use because these are your special angles. All right, so what I'm going to do is what I would recommend you do on your test. Have a unit circle ready to go. Take the unit circle that you already have. I would have already obviously had the completed unit circle, and then I would have taken the time to add on the tangents, root 3 over 3, 1, root 3, undefined, 0. I would at least fill in one quadrant of tangents. And then I would also add on what we need for this section, which is our range for our inverse trig functions. So for sine -1, we use the right side. We use negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. If you have that drawn, and in a minute we're going to add on the cosines and the tangents. But if you have this drawn out ahead of time on your unit circle, you have that stuff marked, this kind of question should take you about 10 seconds. A, find the exact value of sine -1. So I'm looking for where on my restricted unit circle do I have a y value of 0? What's the answer? Do you see a y value of 0? Where is it?
In the x-axis,
So what's that angle?
0.
Yes, 0. Arc sine is the same exact thing as sine -1. They are interchangeable. They mean the same thing. They do something new to mess with you. So, where on my restricted unit circle is sine -1? Negative pi over 2. Last one, sine -1 of negative root 3 over 2. Where on my restricted unit circle is sine negative root 3 over 2? Negative pi over 3. So again, for sine, we're looking for the y. Not the WHY, like big picture. Y as in y coordinate. Look at all the x values on the right-hand side of my graph. They are all positive, right? So I can't restrict it the same way because I need positives and negatives. So for Okay, now we look at cosine. So now we're looking at the x values. Cosine gets restricted differently from sine. If I did the cosines on the right-hand side, all of them are positive, right? Like if you could imagine, go back. Cosine, we actually use the top, quadrant 1 and quadrant 2, because we need positive x's and we need negative x's. Those are these angles. So cosine goes from 0 to pi. So on my unit circle, I would highlight the right side for sine, and I would highlight the top for cosine. When we get all the way through, I'm gonna like pull up a unit circle and show you exactly what I would put on there. But just so you can get an idea to build. So, cosine, pull in my unit circle. Oh, I can't just jump there, it's the last one I put in. The easy thing with cosine is I don't have to change to positive negative angles. I keep the ones that are there. I use first and second quadrant. So arc cosine, same thing as cosine negative 1. Now I'm looking for which coordinate, the x or the y? The x. So where in that range is x positive 1? 0. B, cosine negative 1 of root 2 over 2. Where on my unit circle?
Do you still do what you did for the last unit circle with the pi over 3 negative, it's like negative on the left side?
No. Because the reason we had to do that is so it was one fluid chunk of our curve. We can't jump from like this quadrant to this quadrant. We can't go from first to fourth and have space in between. But we can go from first to second fluidly.
Okay.
Yeah. So where's cosine root 2 over 2? Pi over 4. Where's cosine root 3 over 2?
Pi over 6.
Pi over 6. All of that happened to be in the first quadrant, okay? But it also can be in the second quadrant. If it was negative, it'd be in the second quadrant.
Ms. Chris Butler?
Yeah.
So for the A, what does the 0 refer to on the unit circle?
For the A, the 0, the radian 0, which is here. So all of these are in radians.
Isn't that, isn't the x value that 1 though? Oh yeah,
I love when you answer your own question. Doesn't that feel good? You don't even need me, Sai. You just need to say your question out loud and then you realize the answer.
I do that a lot.
All right, last one is tangent. The good news is tangents are restricted the same as sine, so we already have it. Tangent goes from negative pi over 2 to positive pi over 2. Okay, so on my unit circle, I use the right side for both sine and for tangent. It's really hard to write upside down. I use the top for cosine. Now here's what you don't want to have to do for tangent, is take every coordinate point and have to do y over x every time. That's why we memorize tangent. Like remember when I told you I said you're going to need this later? This is why. Because I already want to know what those angles are, and I want to know what the tangents are at that angle without having to do y over x every time. So here's my restricted angles for tangent, just like for just like for sine, it's going to go from negative pi over 2 to positive pi over 2. The only difference is that I'm not going to say find arc tangent of undefined. You would never get undefined as a question. You might get it as an answer if I find the tangent at pi over 2, but you won't get those. Here's all 3 restricted. Okay, again, this is if you look at the curves. I wouldn't stress about this too much. This is just understanding where it comes from, why we restrict it the way we restrict it. So for sine and tangent, we restrict from negative pi over 2 to positive pi over 2, and from cosine, we go from 0 to pi. Okay, here I'm going to do my last unit circle. This time I'm going to put all of it on there. I should have just copied it from before. Okay, so I'm going to do an arc here, and I'm going to say this is both sine and tangent. Then I'm going to do an arc here, and this is cosine. Also on my unit circle, I'm going to put the values of tangent. So I would at least do your first quadrant, but you can also do the first and the fourth. This tangent is root 3 over 3. This tangent is 1. This tangent is root 3. This tangent is 0. This tangent is undefined. So the rad equals tangent. This would be negative root 3 over 3, negative 1, negative root 3, undefined. I would also add on my negative angles. So negative pi over 6, negative pi, nope, that's not negative pi over 6, that's 0. Negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So before you take this test, you want to alter your unit circle to include all that stuff. In previous years, I let them fill out a unit circle, but they had to do it from their brain. Okay, again, a Corona perk, you're gonna get your unit circle. The downside is God help you when you start to have to know this for a standardized test, because none of it's gonna actually be in your brain. But we'll cross that bridge when we get there. You guys don't have to. All right.
This one, it's like the total one, right? With everything from...
Yep. So I put all 3 curves on it. Yep. So now I'm looking for where the tangent is positive root 3 over 3, which is where? Pi over 6. Where is the tangent negative 1? Negative pi over 4. Where is the tangent negative root 3? Negative pi over 3. These have to be your time saver questions. You have to be able to do these fast. Not many. 2 maybe, because you're gonna see there's different kinds. These are using your unit circle, but we're also gonna learn how to use our...
What does it mean when it says arctan again?
Arctan's the same thing as tangent negative 1. Those are the same things. Oh,
Okay, so
yeah.
just a different order.
Yep. Just another way to mess you up.
Okay, thank you.
Yep, you're welcome. Good? Yes? Okay. What happens if it's not a unit circle based angle? You need a calculator. We already did these kinds of questions. We just did them in word problems, right? If I had a right triangle and I asked you to find the angle of it, you were already using these buttons. It's the same thing. So if I tell you that the sine of a function is 1/4 and I want you to find the angle, you just simply do sine negative 1 of 1/4. You just have to be in radians for these. And this is where this is where the confusion is going to come into play. All of the inverse questions mean radians. Whereas word problems, where you're solving for an angle of elevation or an angle of depression, degrees. Your test is going to flip-flop between degrees and radians. Get comfortable with your mode button. So practice it. Just do sine negative 1 of 1/4. You should get 0.2527. Again, your mode should be in radians. If you're not in radians, you're going to get the wrong answer. And then do second tangent negative 9.65, and you get negative 1.4675. These should be easy questions. But if you put them in the wrong mode, you lose all those points, and there's no work to save you. So you need to be careful.
Ms. Chris, when you're entering the graph for sine and cosine or tangent from last lesson, it didn't matter if you had it in degrees or radians.
It needed to be in radians if you wanted your x-axis to show angles that are in radians.
Okay.
Yeah,
Thank you.
good question. All right, so use the calculator to find the 4 decimal places for each function. Second tangent, negative 5.2. You should get negative 1.3808. Second cosine 0.2. You should get 1.3694. Second sine, because that's the same thing as arc sine, 0.8. So this is the same thing as sine negative 1. 0.9273. Be careful on your rounding. Pay attention to what it says. If it's 4 decimal places, you need 4. If it's 1, you need 1.
Is that a negative sign in
Yes, this is a negative. Yeah.
Just for my
Yep. Easy stuff, right? Sucks to lose all those points because you're in the wrong mode. Inverse, negative ones, whatever it is, these you need to be in radians. All right, this says use an inverse trig function to write theta as a function of x. So we're back to SOHCAHTOA. We have our right triangle, right? So if theta is here, what's the relationship to that side? Opposite, this one? Hypotenuse. So which trig function am I going to use? Sine. So the sine of theta would equal x plus 2 over 6. So it says use the inverse trig function. This means sine negative 1 of x plus 2 over 6 would equal theta. We can't actually solve this because we don't have a side. If we actually had a value for x, we'd be able to solve it. But that's all it wants. Just write it in terms of the other one.
So that's your answer?
Yep. Again, if there was an actual value there, we'd solve it.
If there's, for when the test.
This is composites of functions involving trig functions. So this is actually like a 2 function in 1, okay? It will say find the sine of something that has a cosine of this. And so you're using the cosine, you're using what's inside the parentheses to set up a triangle or to use your unit circle to then find the function on the outside. So these look a whole lot more complicated than they are, okay? You just walk through and you work innermost parentheses out. Hopefully this should work. So A says find the sine. Now, if I'm finding sine of something, this has to be an angle, right? This should be, I don't know why, year after year, I do not fix this. Those need to be switched. Sorry. Sine negative 1 needs to be on the outside. Sine 5 pi over 6 needs to be on the inside. Sorry, that needs to be switched. Okay. So I am finding the inverse function of something. This needs to be a value, not an angle. But on the inside, I'm finding the trig function of an angle. So work inside out. Start with sine 5 pi over 6. How do I find that?
You can just find on the unit circle.
I go to my unit circle. Good. Was that you, Matt? Good. Matt, I miss your voice, by the way. You haven't been talking to me a lot lately. I thought about it. All right. Sine of 5 pi over 6. I go to my unit circle. I look at 5 pi over 6. I find the y. Where's the y at 5 pi over 6? 1/2. Now that whole parentheses gets replaced with 1/2, and I'm finding the sine negative 1 of 1/2. So when I find the initial function, my unit circle is not restricted, but I'm finding the inverse function now, it is restricted. Sine is only the right side, where on the right side of my circle is y 1/2, pi over 6. So be careful because people see sine negative 1 and sine and they cross it through and they write 5 pi over 6, and that is wrong. You have to work with your non-restricted unit circle first and then your restricted one second. Okay, now B is different. B is the sine on the outside and the cosine negative 1 on the inside. And is 5 over 13 on my unit circle. No, what do we do when it's not on the unit circle? Oh, we do nothing. Oh, that's a bad answer. You do what?
You make a triangle.
You make a triangle. Good job. So I'm going to draw a triangle. I don't know theta, but I'm going to put it in the corner. Cosine 5 over 13.
Is it negative?
This is right this time. Yeah. So this would be adjacent is 5. Hypotenuse 13. What's my missing side?
12.
12. Good. Remember, those triples are going to save you a ton of time. Now, what's the sine of that same triangle?
Uh, 12 over 13.
Yep. So we use the inside to set up the triangle. And then we use the triangle to answer the outside.
Because the negative one.
Miss Chris.
Correct. Yeah?
So for that one, it's not supposed to say sine -1.
No, this is correct. So the negative one has to come on the value and the non-negative one has to come on the angle. Notice this is an angle, right? So this needed just regular sine, but this is actually the value of cosine, so it gets the -1. The typo's just in the first one.
Okay, thank you.
You're welcome. Okay, so now look at this, the last one. I start with tangent -1 of 2√3/3. That's not on my unit circle, right? So I set up a right triangle. Tangent is opposite over adjacent. I put theta in the corner. And I have to find the missing side. This time I have to use the Pythagorean theorem. So 3 squared plus 2√3 squared equals the hypotenuse squared or the radius squared, 9 plus, this would be 4 times 3, 12. 21 equals r squared, so r equals the square root of 21, which can't be reduced, so it's left like that. Now what's the cosine of that same angle?
Square root of 21.
Yep, and then we rationalize. And then we simplify.
Okay, that's the end of the notes for today. So please make sure you submit your notes and then you can use the remaining time to work on the 4-7 homework.